this and get overwhelmed by the fact that I got an infinite number of charges here, or a huge number of charges here, and try to find the electric field of each. Or the shortcut is, oh, that's the same as just saying I got a point charge right there. So if I go, what is the electric field at point P? I have some charge here, we'll say 3 microcoulombs, radius of 5 centimeters, and I am 7 centimeters away from the middle. Or given the way I write test, I might say 2 centimeters away from the closest point on the sphere. What is the electric field at point P? I got spherically symmetric charge here, so I can treat it as a point charge located right there. So my electric field at point P is K Q over R squared. Which is something spectacular. So would be kind enough.
That's 0.07 squared.
Yes.
Is it a pretty big number?
Probably.
Yeah.
Say 5.5 times 10 to the 3, 4, 5, 6.
So roughly 5.5 million newtons per coulomb. Okay, anyone else get the same thing? I got a nod and 2 shakes. Whatever the number happens to be. .5 meganewtons. So that's point P there, so let's come up with a point P2 here. So the electric field at point P2, and let's just make it 3 centimeters away from the center. What is the electric field at point P2?
Never mind. I was gonna say, what would be?
Point 2 is inside.
Yes, it is. Therefore,
would it be the same as point 1 or no?
it would be the same as point 1,
Okay.
which is,
The point charge at the side.
ooh. I assume when you said same as point 1, the same as if you were 0.1 centimeters from the center, or point,
The
well, it
same.
depends on what the point 1 is.
I was talking like where the first one, like point, this is point 2, right? So point 1 was the
P1.
P1.
Oh,
This-
sorry,
this is P1.
sorry, not the same as point 1.
No, okay.
Yeah, sorry, I didn't listen to the words you said, and I
No,
assumed some stuff, I apologize.
Correct
Daniel.
me if I'm wrong, but isn't it like at this charge, like isn't it 0 in the center, and but all the excess is like stored on the edge or the surface?
So the electric field in the middle is again,
Pardon?
so the electric field in the middle at 3 centimeters from the center,
0?
yeah, it's 0. You can't treat it like a point charge located at the center of the sphere unless you're outside the sphere. Now, there were some things that I probably should have said, they were very clear in my head, but I don't think I articulated it. Excess charge on the surface here, which means it's either a conductor with all the excess charge having moved to the outside, or it's an insulator and I put all the charge evenly distributed around the outside. If I made this a solid insulator, and I wanted to find, and I had uniform charge distribution throughout the whole thing. If I wanted to find the electric field at this point here, I can assume it's a point charge because it's spherically symmetric. If I wanted to find the electric field at this point right here, recognize that at this point right here, there's a certain amount of charge that's farther away from the center than it is, and a certain amount of charge that's closer to the center. All the charge that's farther away from the center, I can ignore. All I have to do is figure out what is the electric field, or what is the charge closer to the center than this charge is, or than this point is, and then I can treat it like a point charge. Let's do it. All right, so total charge is 5 nanocoulombs. I am looking at a point here that is 2 centimeters away, and with a total radius of 5 centimeters. Let's use a different number, 6 centimeters. And I want to find what is the electric field at this point. If I think about this solid insulator as basically you've got an inner core sphere, and then you've got this thick shelled sphere around it. The thick shelled sphere around it we can ignore, because from his point of view, that's out. This is inside that sphere. It's not inside this inner core. Since I said the charge distribution was even, or implied it, or thought it intensely, and you were supposed to read my mind, I need to figure out how much charge is in this inner core. Well, I know charge density is charge divided by volume. If it's a uniform distribution, it's the same density everywhere. So 5 nanocoulombs is to the volume of the whole thing, 4/3 pi times 0.06 cubed. That's my charge density. Volume of sphere, 4/3 pi r cubed. My inner part, I know that the charge is going to be whatever my density is times the volume of the inner part. Well, we call this Q sub I. So this would be 5 nanocoulombs over 4/3 pi times 0.06 cubed, that's this, times the volume of that inner part, which is 4/3 pi times 0.02. Four-thirds cancels out, pi cancels out, saving ourselves a little bit of trouble there. And we end up with 5 nanocoulombs over I guess 3 cubed. Five 27th nanocoulombs. The 3 comes from 0.02 divided by 0.06. This is the charge that is in that inner core. In other words, closer to the center than my point P is. And so now I can treat it like a point particle with that charge. And so my electric field at my point P here is 9 times 10 to the 9th times 5/27 times 10 to the negative 9th. Yeah, I made it nano. Divided by 0.02 squared. So obviously, so like thirds times 2,500. So like 3,700-ish. What, anyone get?
I got about 16,071
16,071.
newtons per coulomb. Sorry, 16,071. There's a zero in
Oh,
the six. Yeah.
So somehow my estimate got way off there.
And I could be wrong too.
Anyone else get this?
I got something different.
What'd you get?
I got a big number.
Okay.
I got like 4166.66.
4166.
0.66. That's me.
So that ballpark of what I did in my head. So I'm liking that one better just for my own ego's sake. And then Brooke got some, I'm assuming a larger number.
Yes. I'm trying to do the like scientific notation, because it's the like 4166, but like add 4 more sixes.
That's
Oh.
5/27, correct? Am I reading that correctly?
Yeah, 5/27.
5/27.
To the negative fifth.
Negative
Nine.
9.
Oh, I thought it was, sorry. That's
No,
what I
no,
changed.
negative 9.
And then divided by 0.02 squared, right?
Yes.
Okay, I got it now.
All right.
Wait, which one did you get?
I got your answer.
Oh, okay.
All right, the important thing though, we'll get smoother. The important thing is that we have covered chapter 18. So we can talk about it on Wednesday because time's up. But we need to establish what master set and quiz are. Any objection to the quiz on chapter 18 being a week from today? And master set also do a week from today, or do you want a little bit more time, a little less time?
You said the master said next week, and then you said the quiz is,
Quiz is a week from today.
okay,
Master set do,
I'm good with them both being Monday.
both being Monday? Okay.
yeah.
All right. If you have some personal issue where next Monday does not work for you, then please talk to me individually. But master set 18, quiz 18 on Monday. And fun will be had by all. It's posted on Blackboard. The lab that you have this coming Wednesday is, I'll bring what you need. If you have an electronic copy of the book, or you have access to an electronic copy, and most people do through a phone, then please be prepared to use that. If you don't have easy access to it, such as your phone really doesn't work that well, or you're cool and you have a flip phone, then there are textbooks there which you can use as reference as well. And there's a computer in there also if needed. But, yes.
I had a question about last week's lab, the like one that we're taking over the video.
Okay.
Okay, so I was recording.
All right, I'm gonna stop this recording.